I got it.
You got it?
I had to do that little squiggle thing because she changed my document camera. I
Gotcha.
forgot. Okay, thank y'all.
No problem. Thank you.
Uh-huh. Alrighty. So make sure you got your journal done. We're going to be doing a new unit over measuring matter. And we'll have a quiz over Sig Figs, which we're going to spend several days on Friday. So just one quiz this week. So some important things going on. Sig Fig quiz on Friday. I do have tutorials on Tuesday and Thursday. So if you missed the test, if you were absent or failed the test and want to retest, then you need to zoom into one of those. But please email me ahead of time or send me on Sports U to let me know that you'll be coming in. Go into Parent Portal and double check your grade because some of y'all had a few extra points. You got 10 points for doing the review. So that brought some of y'all up to passing. You only need to do the exit ticket if you're absent. I'm posting one in the classroom, but that is for attendance purposes. So if you're here virtually present, you do not have to do the exit ticket. Our journal test will be next week, either next Tuesday or Wednesday. So please make sure that you're up to date with all of your journals. Either get them from a friend, or if you're missing one, then you need to email me so I can help you get caught up. We're not going to have a 6 weeks test next week as far as a cumulative one. We will have a test over this unit, but it won't then also go back and cover matters. So it'll just be over what we're talking about now. Anybody got any questions on that? All right, so if you will look into your Google Classroom, we are going to be doing, we're going to be talking about significant figures. So under notes and PowerPoints, if you'll open that up, and we're going to do the PowerPoint presentation. And when I ran it off for the people that were here, it was missing a few. I'm hoping that it's all here. All right. All right, we're going to be talking about Sig Figs, and Sig Figs can be hard for some people. And we use them the whole year long. So it's important that you take some time, and I'm spreading this out over, 3 or 4 days, that you really take some time to work at it and to figure out what Sig Figs are so that they won't come back to haunt you as we move through the year. Because once you've learned about Sig Figs, any calculation that we do, you're going to have to answer it with the correct number of Sig Figs. Significant figures or Sig Figs apply in science classes because our numbers mean something. Like in math, you're dealing with numbers, but it's not a measurement. In science, it's a measurement with a unit. So your calculations cannot be more precise than the digits given you in a measurement. So in other words, if I'm trying to find the volume, which is length times width times height, and I say it's 2 inches by 2 inches by 2 inches, I can't then do that calculation and say it's 8.0000. That would infer a very precise answer. I can't have my answer be more precise than the measurements that I started off with. So that's what Sig Figs are about. So significant digits are a measurement that consists of all the digits known with certainty plus one final digit, which is uncertain or is estimated. So anytime that we do a measurement in chemistry, we're always going to be able to see some numbers based off of how good the instrument is, and then we're going to estimate the last one. So significant figures are used to indicate the precision of a measured number or to express that precision of a calculation with measured numbers. So once again, we're going to start off just by identifying how many sig figs the number has, but really it becomes important when we start using them in calculations. So if this was a ruler I was using and I just had 0, 1, 2, 3, 4, 5, without a lot of demarcations in between, that's not a very precise measurement, and I can't make very precise measurements off of it. So if I had this red line and I looked at it, the only number I know for sure is 1. So let's say these are inches. I know it's 1 inch, but the next number I have to estimate. So I'm going to estimate it's about middle of the way through. So I would say it's 1.5 inches. First number is known for sure. The second number is always going to be, in this case, is going to be an estimate. So they're saying this was 1.3. You can see whenever you have something that doesn't have a lot of demarcations, it's kind of hard to be able to make good measurements. If I had another measurement that was right here, exactly on the 2, I would know the 2 for sure, and then I would estimate my second number. So I would estimate that as 2.0, the 2 being known for sure, and the 0.0 being my estimation. So if it, in any measurement, the digit farthest to the right is considered to be the estimate, or the very last digit is always considered to be your estimate. If we were looking at this little, a couple of rulers here, we can see this one just says 1, 2, 3, 4, 5, 6, and this one has a lot of demarcations. If I'm trying to measure this little gray piece of paper on my first ruler, what would you estimate that that measurement was, somebody? 4. You can estimate it as 4. We know it's 4 for sure, and then we can figure out what it is. We would estimate the second. So I would say like 4.2. Somebody else may say 4.3, but we would make an estimation like that. What's wrong with my thing? So the length is between 4 and 5. The 4 is certain, and then past that we would do our estimation. In this case, we said 0.2, 0.3 they're saying, but both numbers would be considered significant. Just because your last number in a measurement is estimated, that does not mean that it's not significant. Now, if we come back and we measure here, but now we come down and use this lower one, what would somebody say that the measurement would be here? .4. Well, let's see what we got here. Here's my 4. I know that for sure. And then I can count 1, 2. So maybe 4.2. Those two numbers I know for sure. And then I would estimate my next one. So maybe 4.21. Somebody else may say 4.20. But I know the 4 for sure. I know the 0.2 for sure, and then I always make one more place the estimation. So the edge of the rectangle is between 4.2 and 4.3, so we are certain of the 4.2, and then like I said, we always estimate one place past. So anytime we're doing a measurement, or anytime you see a measurement, the last number is always an estimation. And how many places past the decimal you would go with the measurement is going to depend on what type of either, in this case, a meter stick or a balance or volumetric flask or something, what type of equipment you have. So here we have graduated cylinder, same thing. Hopefully y'all remember that's called a meniscus. So remember, I measure at the bottom of the meniscus. Here's my 50. It goes up to 55, 56. So I know 56 for sure, and I'm going to estimate one place past that. So I would estimate it as 56.0. These two I knew for sure. The 5 and the 6, I estimated my last one. So remember, the last digit in any measurement is always the uncertain or the estimated digit. It is significant even if it is not certain. So just because you estimated it does not mean that it's going to be an insignificant or non-significant number. The more significant digits a value has, the more accurate the measurement would be. We saw on that one where we were using either one that just said 1, 2, 3, 4, or we had a lot of demarcations. You're going to get a more accurate measurement the more demarcations that you have. All right. I'm going to put on this little YouTube video and let y'all watch it for. It's not real long.
Hey, it's Professor Dave. Let's talk SigFigs.
Now, Grammarly is one of the best extensions that I personally downloaded, and it's something that I use on a daily basis. It's also super helpful to show alerts on your clarity, engagement, as well as.
Hey, it's Professor Dave. Let's talk SigFigs.
He knows a lot about the science of Professor Dave explains.
Humans have a need to communicate their experiences with one another. How far apart are two cities? When did something happen, and how long before it happens again? This is why we developed units of measurement. Some correlate with natural phenomena, like a day or a year, which are based on the motion of the Earth, but many are arbitrary, like most units of length and mass. When we participate in measurement, we have to be aware of some limitations. For example, how many people are in this crowd? Can we say 10,000? What about 10,400 or 10,472? We have to be careful not to make an estimate that is more precise than our measuring abilities allow. So when we use measuring devices, we only estimate one digit further than the level of precision inherent in the instrument. Here, we can estimate 2.33 centimeters, but not 2.33481. We do not have access to that level of precision. So any measurement will have a certain amount of significant figures, or SigFigs, associated with it that display how precise it is. Here are the rules for determining how many SigFigs are in a value. 1, any digit that's not 0 is significant. 2, zeros in between other non-zero digits are significant. 3, leading zeros, ones that come before the first non-zero digit, are not significant. And 4, trailing zeros, the ones that come after the last non-zero digit, are only significant if they are decimal zeros. So 10,000 only has one significant figure, which really means it's about 10,000, not exactly 10,000. If we bring back that same crowd and one more person shows up, can we estimate 10,001? No, because we have only estimated to one SigFig. So anything from 9,500 to 10,499 would round to our estimate of 10,000. When we do calculations, we have to pay attention to the number of SigFigs. If we are adding or subtracting, our answer will have as many decimal places as the value with the least number of decimal places. If we are multiplying or dividing, our answer will have as many SigFigs as the value with the least number of SigFigs. Whatever our answer is, we will have to round up or down at the appropriate digit. 5 or higher means round up. 4 or below means round down. Let's check comprehension.
All right. All right, so we'll do some check as we go along here. So those are the rules that we're going to be looking at. And like I said, you'll have to memorize them and be able to work with them, because from now on, any calculation that you do, you need to make sure that your answer has the right number of SigFigs. When you're multiplying and dividing, which is what we do most of the time in chemistry, your answer should have the same number of SigFigs as your least precise measurement. So that's why it's important that we start off by being able to recognize how many SigFigs a number has. And once again, this all goes back to the fact that when I do my calculations, I cannot end up with an answer that seems to be more precise than the measurements I started off with. All right, so we're going to look at these rules. The other thing that is attached to this PowerPoint is like a little cheat sheet that has just the rules and just the flow chart that I'm going to show you in a minute. So you don't always have to pull out the PowerPoint. So your first one is, if a number contains no zeros, all of the digits are significant. So when we're looking at significant figures and we're talking about how many significant figures a number has, we're really considering the zeros. That's what we're making a decision on. If it doesn't have any zeros, those are the easiest ones. Any non-zero number is always significant. So that means all of these where there's no zero involved is going to have that many number of significant figures. So A is going to have 3. B, once again, no zero, so everything is considered significant. So you would have 4. C, no zero, so that one would be 2. And the last one, no zero, so that would have 3 significant figures. So that's kind of our easiest rule. Now we'll start throwing some zeros in there. The next rule is all zeros between 2 non-zero digits are significant. So I call these sandwiched zeros. You see how those zeros are sandwiched between non-zero numbers. Any zero that is sandwiched between a non-zero number is considered to be significant. So this zero, because it's between the 5 and the 6, that would have 3 significant figures. B, once again, these zeros are between non-zero numbers, so it's going to be considered significant. So this one would have 5 significant figures. And how many would my last one have?
6.
6, exactly. Thank you. Okay, so that's our second easiest rule. I could have a 1 and I could have 20 zeros and then finish it with the 1. Everything would be considered significant. That would be 22 significant figures. That would be a pretty large measurement. All right, now we're going to look at some of the other ones where they get a little bit harder. Zeros to the right of a non-zero digit, if they are to the right of a non-zero number, but not sandwiched between non-zero and a decimal point, they are not significant. So in other words, these zeros that are behind a non-zero number but do not have a decimal behind them are considered placeholders and they are not significant. So this one, 4,830, that is considered a placeholder. So that means that this is only 3 significant figures. So that means that on whatever they were using to measure this, the 4,000 place could be seen, the 800 place could be seen, the 30 place was estimated, and they put there that 0 as a placeholder to hold the magnitude of that number. So A would be 3. How many would B have?
1.
1, yes, sir. Thank you. And what about C?
1.
Also just 1. Perfect. All right. Now, if we throw a decimal in there, because notice these numbers are the same, the only thing that's changed is we threw a decimal at the end. So now if you have a 0 behind a non-zero number and before a decimal, those are now considered to be significant. This is now saying that whatever instrument was used to measure it, you could read the 4,000 place, you could read the 800 place, you could read the 30 place, and then you estimated the 0. So this is saying like it's exactly 4,830. So this decimal makes all of those zeros become significant. So A now has 4 significant figures. B has 2. How many would C have?
4.
Anybody?
4.
4, yes. Putting that decimal right there makes these become significant. All right, now we're going to look at a couple of rules when we're looking at numbers that are less than 1. And to me, these are the ones that are kind of a little bit harder. So in decimals less than 1, zeros to the right of a decimal point. So we're talking about these zeros right here. To the right of a decimal point and to the left of the first non-zero digit are never significant. They're simply placeholders. So these zeros right here are placeholders just like they would be in math. So these are what we're looking at. If I have a zero that is to the right of a decimal, but before a non-zero number, it's considered a placeholder. Let's see, I got a question. Yes, sir. That's right, Roddy. So this one would only have one to start off with. If I can get my thing to work. Come on. There we go. A would have one. What about B? Anybody?
2,
2. Thank you. And what about C? 2. I got another one. Yeah, C would have just one. That's right. These zeros right here are considered insignificant. So we're just looking at those numbers. All right. One more. Okay. Now we still have some decimals involved. So now if I have a zero that is behind a decimal and behind a non-zero number. So see, this zero right here is behind a decimal, and then it's also behind 8 and 7. Then those are significant. So this one would have 3. The 8 and the 7 are obviously significant. This 0, because it's behind a decimal and behind a non-zero number, is considered significant. What about B? Anybody want to take a guess on B? If
2.
it's behind it, I'm sorry, go ahead.
2,
Did you say 2? That one would have 2. This one, what about C? How many would that have? He's killing me with my chat room here. C, exactly. 4, as Roddy said, it would have 4, okay? These non-zero numbers would be always significant. So really the 0 is what I have to decide on. Since it's behind a decimal and behind a non-zero, it's considered significant. D, anybody want to just take their mute off and tell me how many D have?
Five.
5, perfect. Every one of them. And what about E?
3,
3, yes, that's right. All right. So I will tell y'all that practice makes perfect. The more time you spend on this, as we started at the beginning, the easier it'll make the whole year for you, because it's something that, like I said, can affect things from here on out. All right, y'all take a minute, and I think y'all can type on your, I'm pretty sure there's a box over here where y'all can type onto your PowerPoint. So take a minute and see if you can figure out how many of these 10, how many of SigFigs each one of those has. And type it into your PowerPoint.